In this video, we're going to cover percentiles. And you can see here right off the bat, we have two different definitions for what it means to be a percentile. They often will differ if we're looking at smaller data sets, but when we're looking at bigger ones, they're very, very close to being equivalent. And I'll have us do an example of each so that we can kind of see that. So what the first one is here is it says the percentile of X. You're going to find that by looking at the number of data values less than or equal to X, divide that by the total number of data values, and then multiply by 100. So in other words, if somebody scored 90th percentile on the SAT, then that means that they scored better or equal to 90% of the students who took the SAT. So let's go ahead down here and actually maybe we'll look at actually what this says in the second definition, because it is a little, it takes a little more work. Okay. So it ends up that if you take the number of pieces of data you have, and we'll call that N, we can identify the location of the Pth percentile by using this little formula here, L equals N times P over 100. And P is just the percentile. So if we want to find the 90th percentile, we'll replace P with a 90. Okay. So if this L comes out to be a whole number, then you actually want to average the number in the Lth position and the number in the L plus 1th position. Okay. Now, when I say in position L and position L plus 1, this is assuming that our list of numbers is in order. So if your numbers aren't in order, you need to make sure to do that before trying to use this little formula here. Now, if it doesn't come out to a whole number, you're just going to round L up to the nearest whole number, and the Pth percentile will be the number in the position corresponding to that rounded up value. Okay. And so let's go ahead and give this a try right here. So we have an experiment. It says here are the survival times in days of 72 guinea pigs after they were injected with infectious bacteria in a medical experiment. Okay. And we're going to use definition 1 to answer question A and definition 2 to answer question B. And so it says what percent is 200, or what percentile is 243 days? Okay. So first of all, here's 243. And I also want to point out our data is already in order. So is what we need to do is just figure out what position this number is in. Okay. We want to know what percentage of our data are equal to 243 or less. Okay. So let's just point out that this is going by 12. So this is the 12th number. This right here is going to be the 24th number. 36th, again, just counting by 12s. 48th. And then the last one we need to point out before we start counting by ones is this would then be the 60th. So that means this would be the 61st number, the 62nd, 63rd, 64th, and then finally this is the 65th number in our ordered list. Okay. So that means when we go to compute our percentile, we want to write that we have 65 out of how many here? So out of 72. So 65 out of the 72 numbers in this data set are equal to or less than 243. Okay. Now, this right here at the moment is just going to give us a decimal. Okay. To convert it to a percentage, all we have to do is just multiply this by 100. And so let's go ahead and do that. We'll do 65 over 72, and then we can multiply by 100. So we're getting about 90.3%. And I'm going to write that. But I want to point out when we do talk about percentiles, One thing I didn't mention is they do need to be whole numbers, and specifically, they can be 1, 2, 3, all the way up to 99. Okay. So we won't talk about a 0th percentile or a 100th percentile, only 1 through 99. So this means that that 90.3 that we have, we want to round that to a whole number, okay, the nearest whole number. So I'm going to say that this is the 90th percentile. So definition one is pretty good when we're given a number and want to identify its percentile. Definition two is going to be good for going in the opposite direction. So now we want to find the 90th percentile. So we need to identify its location. So I want to use that formula, L equals, and let's go up and remember what it looks like. It was N times P over 100. And again, N is how much data we have. So we have data on 72 guinea pigs. So N is 72. And then we want to multiply by P over 100. Okay. And so let's go ahead and see what that gives us. That's really just 72 times 0.9. Might be a quicker way to write 90 over 100. So we're getting 64.8. Let's go ahead and record that. And according to definition two, when we get a decimal, we want to round this up. So if we round up, that gives us 65. So we're looking for the number in the 65th position. Well, we've already noted where that is. It's right here. We could just count until we get to that 65th number. And so we get 243 days. And so if we were to interpret, say, this one over here or this one really, because we wound up really with the same results, it's just different side of our result. Okay. So the idea is that about 90% of guinea pigs survived 243 days or less, is what this is telling us. So only 10% of guinea pigs lived longer than 243 days after the injection. All right, now um, we see that these two definitions match up really nicely, but let's maybe look at a smaller data set and see that there actually is a discrepancy with small data sets. So I'm going to try to choose maybe 4 random numbers over here on the right. Let's say our data, see if I can scoot this back over. There we go. Our data, let's say we have 1, 5, 7, and 21. So if we were to say find what percentile it is, let's do that first. So we don't have any units on this, so I don't know. This is 5 something, okay? But if we were to find this percentile and we were to use definition 1, is what we would say is, well, there are 2 numbers that are equal to 5 or less. So I have 2 out of a total of what, 4 numbers. And so we get a half. Now we wanted to multiply this by 100 to turn it into a percentile. So maybe I'll put times 100. So this gives us 50th percentile. Well, I'm going to ask us to do something very similar here now. Let's see here. I'm debating which percentile I want us to have. I think I'll have us try to find maybe, um, let's find the 40th percentile. Or let's go 45th, actually. And we'll use definition 2. So if I already used that little formula, we'd have L equals N. So N here was just 4 times P over 100. Okay. And so P this time is 45. And again, out of 100. So let's see what that gives us if we do 4 times 0.45. We get 1.8. And is what we were told to do is to round this up. So if we round this up, we get that what we're going to look for is going to be in the second position in our ordered list. So is what we're getting here is we're getting that our 45th percentile, according to this formula, is our second number, which is the 5. Okay. So I'm going to come over here and say, well, 5 is our answer. Okay. But is what I want you to see is we found that the percentile using definition 1 of 5 is the 50th percentile. And then if we go to try to find the 45th percentile, on the other hand, we wind up getting 5. So 5 can't be both the 45th and 50th percentile. Okay. Now, here's the thing. There's more than actually just 2 definitions for percentiles. There's actually many. Okay. Um, so I'm going to have us mostly using definition 2 here. But is what I want you all to just be aware of is that with small data sets, talking about percentiles is a little less meaningful because, as you can see here, there's a discrepancy. When we have our larger data sets, talking about percentiles makes a lot more sense. And again, you can see here we didn't have a discrepancy between the 2 definitions. We ended up with the really 65 or 243 as being the 90th percentile using either definition. All right, so let's go ahead and move down here. So this time we're trying to find the 75th percentile when our data has been given to us in a frequency table. Now, usually we're not going to have a third column here, but I knew that I was going to want to find something that we'll call the cumulative frequency. Let me see if I can scoot that over so I have a little more room to write the word frequency. There we go. So we'll talk about what cumulative frequency means in a minute. I just wanted to label that. But I also am going to want to find a total here at some point. All right. And so let's go ahead and do this. So if we're looking for the 75th percentile using definition 2, we're going to use that same formula. L equals N times P over 100. So N is how much data we have, how many observations we've made. And so if we look up here, if we want to figure out N, we just need to total up our frequencies. Because remember, is what this chart means is that we have 25 ones in our data set. We have 35 twos in our data set. We have 50 threes in our data set. And we have 30 fours in the data set. And finally, 20 fives in the data set. So there's a lot of data in here. So let's grab our calculator and we'll total those up. I'm going to just scoot this over so you can see it as I type it in. So what do we have here? 25 plus 35 plus 50 plus 30 plus 20. And let me just double check what I've typed in here. All right, and that looks good. Let's hit enter, and I'll scoot the calculator over. We're getting 160. Okay. So 160. So now that we know that, we can come over here and we can write in a 160. We're trying to find the 75th percentile, so P is 75. So we'll just do 160 times 0.75. Let's see what that gives us. So we get 120. Go ahead and record that. So you might remember when we get a whole number, we want to average. Let's write what we're going to do. We are going to average the numbers in position 120 and 121. So now we need to figure out, well, what number is the 120th number? What number is the 121st number? So if we just wrote down all of our ones, we'd have a total of 25 numbers. Okay. If we wrote down the ones and the twos, we'd have a total of 60 numbers. Okay. So all I've done so far is I just added the 35 to the 25. Now if I add 50 to my 35, or 50 to what I currently have, I'll get 110. And again, this is how many numbers we'd have if we wrote down all of the ones, all of the twos, and all of the threes. We'd have a total of 110 numbers so far. Okay. Now that we're on to the fours and we have 30 of those, we'll have a total of 140 numbers by the time we get to the very last 30. Okay. Now, I don't need to fill in this last one here. I just want to point out that this little section right here, where I say the cumulative frequency is 140. Well, is what this really means is that the 110th number was a 3. So this means that the 111th number through the 140th number are all, what are they? All fours. Okay. So if we were to actually average the 120th and 121st number, well, they're both going to be fours. Okay. So I guess I could write that in here that we're going to do 4 plus 4, because we're averaging two fours, and well, we're going to get 4. Okay. And so this right here is our answer. This is the 75th percentile. All right, and then we'll do one more problem here in a second. So we have talked a little bit now about the empirical rule, and I want to point out that we can find some percentiles using this. We'll eventually be able to find any percentile that corresponds to a normal distribution, but for now, it'll have to be the percentiles that are associated with being 1, 2, or 3 standard deviations from the mean. Okay. So that's all we have on this empirical rule. So it says that body temperatures of healthy adults have a bell-shaped distribution with a mean of 98.2 and a standard deviation of 0.62. So if I wanted to, I could actually go in here and start, filling those in. Maybe I'll try to write a little bit smaller here so that there's plenty of space. So 98.2 should go right in the middle. And then we want to add 0.62 to that. Actually, I'm only going to need the left side of this. So I'm going to actually just do 98 minus or actually it's 98.2, isn't it? Let's fix that. 98.2 minus 0.62. So let's record this one, 97.58. Let's subtract away another one after I double check that, 97.58. Okay, good. Minus 0.62. And so we get 96.96. And lastly, I could fill in this one over here if I want to also. I really don't need this one, but I'll go ahead and add it in here too. So minus 0.62. I need to insert a decimal here that I'm missing. There we go. So 96.34 is the last one I'm going to write. 96.34. And let me just double check that. Okay. So you might remember from doing a couple of these that to get 16% using this normal distribution is always either the last three or the first three. Okay. And when we do talk about percentiles, though, we are talking about what are the number of body temperatures, or we're looking for a body temperature such that 16% of people have a body temperature at that level or lower. Okay. So we are looking for this body temperature that would correspond with that line there. Because again, if you total all these up, we have 16% over here. So our final answer then is going to be that 97.58 degrees Fahrenheit. Okay. So again, 16% of people have this body temperature or lower. All right, and that wraps up percentiles.